Welcome. In this video, I'm going to show you how to determine where the absolute extreme values lie of a function on a given interval. Okay, so we're going to follow these 4 steps. Those of you in my online class should already have these written down in your guided notes template. We're going to first find the critical values. We're going to evaluate f at these critical values. We're going to evaluate f at its endpoints. Then we're going to identify the largest and smallest results from step 2 and step 3. Okay, so the first thing we want to do is find the critical values. So to do that, we need the derivative of f. The derivative of f is 1 minus 1 over x squared. Where is this derivative equal to 0? That is, where is f prime of x equal to 0? Well, that's when 1 minus 1 over x squared is equal to 0. Now, I can rewrite this quantity on the left as x squared minus 1 over x squared equals 0. So really what I want to know is, where is x squared minus 1 equal to 0? Well, that occurs when x equals plus or minus 1. If you don't see that, that is because this is a difference of squares on the left. So x equals 1 and x equals negative 1 are my critical values. And now before I go and chat about where this derivative is undefined, I'm going to make sure I make it very clear that our first derivative of 1 minus 1 over x squared can be rewritten equivalently as x squared minus 1 over x squared. So now I'm going to ask, where is f prime, where is f prime undefined? So that would occur when this denominator is equal to 0. That is whenever x squared is equal to 0, so x equals 0 is another critical value. All right, so what are the critical values? Well, looks like we have 3 of them, 1, negative 1, and 0. But before we go ahead and consider all these critical values, let's see which of these are actually on our interval. Well, negative 1 lies to the left of positive 1, so this is not a critical value. And the same goes for 0. This is also not a critical value. These lie outside of the interval. So I'm not going to consider them at all. Oops. So my only critical value then is x equals 1. So let's evaluate f at the critical values. So there really only is one critical value to look at, so that's f of 1 is equal to 1 plus 1 over 1, which is 2. So f of 1 is equal to 2. Now let's look at the endpoints. 1 is both a critical value and an endpoint, and we've already evaluated that, so we don't need to do it again. So let's look at f of 5. That's equal to 5 plus 1 over 5, which is 5.2. So f of 5 is equal to 5.2. Okay, so now let's look at the largest and the smallest values. The largest value occurs here. That's f of 5 is 5.2. That's a maximum. And the smallest is here. F of 1 is equal to 2. So there is a max of y equals 5.2 located at x equals 5. There is a min of y equals 2 located at x equals 1. And I want to point out that very often mins and maxes, so extrema, are identified by using the x-coordinate, even though the extreme, that is the high point here, is 5.2, the y-coordinate. We identify them by pointing out where they are located along the curve, and this one is located, this extreme point, this max, is located at x equals 5, and this one is located at x equals 1. And as you can see here, I went ahead and graphed this. That is, I graphed f of x is equal to x plus 1 over x. That's what we're seeing here. And we're seeing it restricted between x equals 1 and x equals 5. That's what the interval 1, 5. That's what this tells us, where we restrict our graph. And the extreme points occur at the endpoints, a low point of 2 when x is equal to 1, and a maximum, a high point, an absolute maximum, of course, and this is an absolute minimum, the absolute maximum at 5, 5.2.